Hi, this is Doug Renstrom. Welcome to this demo on exploring containers on Google Cloud Platform. In this demo, we will explain how Docker, Kubernetes, Container Builder, Container Registry, and Container Engine work. To do this, we will write a simple web application using Node.js code. We will run it in Google Cloud Shell, containerize our code using Docker, save the container to Container Registry, deploy the container to Container Engine, expose the container via a load balancer, automate the container build and save it using Container Builder, automate and deploy using a deployment file. Now let's write the code to run a web server with Node.js. To write our code, let's start up Google Cloud Shell. Our Node.js program will be in a file called app.js. Let's create that now. Let's just paste in the code. Notice it's just an HTTP server. Very simple. When a request comes in, we're just going to say, hello containers. Our application is also going to listen on port 8080. Let's save that. Now let's run the program in Node. It says our server is running. Let's test it out. We know it's running on port 8080, so we can use web preview right from Cloud Shell to see if it works. Here we'll preview on port 8080. And there we go. Hello containers. Now let's stop the program. Now let's create a Compute Engine virtual machine, and we'll try deploying our Node.js application to it. So in Google Cloud Console, we'll go to Products and Services and Compute Engine. Let's create a machine. We'll just call it Not My Machine. And we'll put it in US Central 1A. We'll accept most of the rest of the defaults, and we'll also allow HTTP traffic since this is going to be a web application, and then we'll hit create. Let's give the machine a moment to start up. Okay, let's copy our program to that virtual machine using Google Cloud Shell. Remember, our program is a Node.js application written in the file app.js. We can use this command, gcloud-compute scp, to copy our app.js file into our machine, which we called not my machine. Okay, it said it copied our file. Now let's SSH into that machine and see if we can get our program working. Let's see if the file is there. There it is, app.js. Now let's see if we can run it. Node space app.js. And of course we can't. The reason we can't is because Node.js is not installed on this machine. Now what we could do is configure this machine to run Node.js, but we're going to use a more automated way. We're going to package our application up into a Docker container. Then we'll deploy the Docker container and run it on Container Engine virtual machines. Let's see how to do that next. To create the Docker image, we first need to create a file called Docker file. Let's use Nano to create that now. Here's the code to create our image. Notice we're starting with a base image provided by Google that includes Node.js. In the second command, we're going to copy our app.js file, which is our application, to the /app folder on the container we're building. Finally, at the end, we're going to run our program just like we did before using node space app.js. Let's save that file. Next, we'll use Docker's build command to build the image. Notice the command is docker build, and then we're naming the image my-web-server. The period at the end indicates, hey, your Docker file is in the current folder. Okay, our Docker image is built. Let's verify that it worked. We'll type docker images. As you can see our image, my-web-server, along with the image we downloaded, which was the base image that we used to create ours. Now let's test our program. We'll test it using docker run. Notice we're going to run our image, my-web-server. We're going to expose port 8080, and then we're going to forward request to port 8080, also to port 8080, because that's what our application is listening on. Let's run it. If it works, we should be able to preview our application on port 8080. And there we go. Our application is running. Hello, containers. If we want to stop the Docker image, we first need to know its ID. So we can type docker space ps. This will show all running images. Notice the first parameter here is the ID of that image. If we want to stop it, we can say docker space stop and then paste in the ID. Our program should be stopped. If we go back to the browser and hit refresh, it shouldn't work anymore. There we go. So now we have a container, but it's in the local machine's set of Docker images. If we want to use it elsewhere, we need to send it to a well-known location. This is a container registry. Google runs one on GCP that is project private. That is, your images are hosted privately. Let's upload the Docker file to the Google Container Registry. First, we need to tag this container. To push your container into the container registry, it needs to be tagged with the gcr.io domain, followed by the GCP project ID that you're working in, followed by the name for your container. This command will do that for us. Notice we're tagging my-web-server with this string, gcr.io, then the project's ID, then the name of our image. Let's do it. Let's verify that worked by typing docker images again. Notice we now have 3 images listed. This was the one we created originally. Now we've tagged that image. This was the base image we downloaded when we created our Docker container. Now we're ready to push this image up to the container registry. There's a command called docker push that'll push images up to Docker's website. We want to use the GCP registry though, so we're going to use the gcloud command line interface to push our Docker container. The command is here, gcloud space docker, then we're going to push our image that we've just tagged. There we go. Let's verify that our image was pushed into the container registry. We can do that by returning to the web console. Let's go to the Products and Services menu and we'll scroll down to Container Registry. And there we have it. Under Images, we see my-web-server. We've shown how to use Docker to build an image and gcloud Docker to get our image into the container registry. We can combine these 2 steps into one using Container Builder. Let's see how that works. Here's our command. gcloud container builds. We're going to submit a build. This is the name of the image we're going to build. Notice we've made it slightly different than the image we've uploaded last time. So it's not my-web server, but my-cb-web server for container build. And we're building the image in the local folder. All right. Notice the one build command, build our Docker container, and then uploaded it to Google Container Registry. So we have a container and it's in the container registry, but we'd like to run it somewhere. On GCP, this is the job of Container Engine. We could also use Compute Engine directly, but then we would have to configure the virtual machines to run Docker. Container Engine is more automated. Let's start by creating a Container Engine cluster. Okay, let's go to Products and Services and choose Container Engine. We'll create a cluster of machines. We'll call it Demo Cluster. And we'll put our cluster in US Central 1A, and we'll accept all the rest of the defaults. It'll take a little while for that cluster of machines to be ready. Okay, our cluster appears to be ready. Let's click on it. Notice the link here, connect to the cluster. Let's click on that. And notice once we connect to the cluster, this gives us the command that we can enter in order to connect to that cluster and control it with Kubernetes. Let's copy that to the clipboard. And then let's return to Google Cloud Shell and we'll paste it in there. Now we've made our connection to the cluster. Let's enter some Kubernetes commands to see how they work. First, we'll type kubecontroller get pods. A pod is like a collection of containers. Notice at this point we have no pods. We could also type kubecontroller get services. Notice we have one service up and running. It's the Kubernetes service. We can also type kubecontroller get deployments. And at this point, we haven't done a deployment, so we see nothing there. Now let's try to deploy our application. We use the Kubernetes command line interface to deploy the app. Notice it's kubecontroller run. This will be the name of our deployment, my-web-server-gke, and our image is the one we've just deployed up to Google Container Registry. At the end, we're saying we're going to expose port 8080. Now it says my deployment was created. Let's try running kubecontroller get pods again. Notice now we have one pod. It's not quite ready yet. Let's wait a second and try again. Oh, now it is ready. Now let's type kubecontroller get deployments again. As you can see, now we have one deployment. The problem is we need to be able to talk to our deployment. Let's set up a load balancer to do that. Again, we'll set up the load balancer using a Kubernetes command. Here's the command. Kubecontroller expose the deployment, my web server-gke. we're going to create a load balancer. Our load balancer is going to listen on port 80, and then it's going to forward requests to port 8080 where our deployment is listening. Now let's run again. Kube controller get services. Notice we have a load balancer, but our external IP address is pending. Let's wait a couple seconds and try that command again. There we go. Now we have an external IP address to the load balancer. Let's see if our application is running. We'll copy that IP address to the clipboard, and then we'll paste that into our browser and see if it works. There we go. Hello containers. Excellent. Let's type kube controller get pods again. Notice we have 1 of 1 pods ready, or 1 of 1 instances ready. Let's try to scale that up. Let's run this command. Kube controller scale deployment, my web server GKE, and we'll set number of replicas equal to 3. Said it was scaled. Now let's call get pods again. Now we have 3 pods, only 1 of which is running. Notice the 2 new ones we created are still creating. Let's run get pods again. There we go. Now they're all ready. We still make requests through the load balancer though. So again, returning to the browser, if we hit refresh, our application is still running, but now we have 3 instances of it. In this demo, we've seen how to use Docker, Container Registry, Container Builder, Kubernetes, and Google Container Engine to automate the deployment of our applications. We have containerized a Node.js application using Docker, uploaded the container to Google Container Registry, created a container engine cluster to run our application, and used Kubernetes to automate deployment, load balancing, and scaling of our application. Hope you enjoyed this demo. I'm Doug Renstrom.